Hi, welcome to 4-H Friday. I'm Sara King, Extension Professional with the 4-H Youth Development Program of the University of Maine Cooperative Extension located in Oxford County, Maine. Today, we are going to do an experiment called Drops on a Penny, which is about cohesion of molecules and measuring surface tension. The purpose of this activity is to understand why water tends to stick together on surfaces. To do that, we will conduct an experiment to find out how many drops of water can rest on top of a penny without spilling over. This involves only a few materials which you will probably have at home. You will need 2 pennies or other coins, water, an eyedropper, a glass, cup, or small bowl, and a surface that you can spill on. This is a great activity to do with youth at any age, and it can be adapted or modified to better suit the needs of an older or younger child. For example, with a younger child, you might help them keep their hands steady and use a quarter instead of a penny. And for an older youth, you might challenge them to repeat the experiment with different types of liquids to find out how the molecules of that liquid affected surface tension. You might also try this with soapy water as well. Also, as you conduct this experiment, be thinking about varying results. Scientists repeat experiments time and time again, trying to control for all factors, but sometimes they do experience different results. What that means is, you could do this experiment 3 times and might possibly count a different number of drops each time you repeat the experiment. That's okay. That's part of science. The repetition is used to verify results and often lets you see different patterns and trends within your experiment. You may have noticed that when water spills somewhere, it spreads out, but also stays together in droplets. That's because of the tiny molecules in water that are all attracted to each other. We'll call that cohesive force. So what we're going to do is use the dropper to fill up the penny with as many drops of water as we can without it spilling over. Make sure you count the drops. So I'm going to start by inserting my eyedropper into the water, squeezing and filling up with as much water as I can. I'm going to place the dropper slightly above the penny so it's not touching as I release the drops. That was 14. I'm going to refill. "21 drops. So what's happening here is the molecules in the center of a drop of water are being pulled evenly in all directions by neighboring molecules. Those at the top are being pulled down by the molecules below. That's what's creating the surface tension, and that's what allows the water to kind of bubble up over the penny's surface. So I was able to get 21 drops of water onto my penny before the water started to spill over. So I challenge you to get 21 drops on your penny. I also challenge you to think about or possibly try a variation with dish soap. Soap actually reduces the cohesive force of water molecules and breaks the surface tension. So my question to you is, what would happen if you added dish soap to the water and then completed the experiment? Please share with us how many drops of water you were able to get on your coin of choice, what happened when you added dish soap to the water, and any other variations that you decided to do. You can share this on our University of Maine Cooperative Extension Oxford County Facebook page and use the hashtag Maine 4-H Fridays. Thanks for joining.